Hi everyone, here's a video for the Chapter 7 test review, free response 3 and 4. Remember, you get 15 minutes for these, and I'm going to do 2 in 15 minutes. So this is about half time, okay? You should have this done and you're just watching this for help. So anytime you're given g equals an integral, then if you were to plug in a value, you would be finding area, all right? Now what we're going to do is this says find g of 3, g prime of 3, and g double prime of 3. Now, friends, you cannot plug in 3 into g prime until you find g prime of x. So that's always step 1. So we're starting on A. I didn't even read it. I see shapes here, so I know I'm going to have to be finding some areas. But let's draw on here g prime of x means I'm going to take the derivative of each side. So the derivative here and the derivative here cancels the integral. Now this is the most basic version of the derivative of an integral where we're just going to end up with f of x. Okay. Now when we plug in points into here, into this graph, we're just going to be finding points. So anytime it asks about g prime of a number, we're going to look at the points, the graph of f, because when we took the derivative, that's what we got. We got f. Now we're going to take the second derivative. So we're doing the both sides, the derivative of both sides, and the second derivative will be the derivative of this and this. So this f becomes f prime of x. So anytime they ask a question about g double prime, we're looking at f prime, which means we'll be looking at the slope of f. It's like a puzzle. So this is going to be slope, like that. Okay, let's start on A now. Show the computations that lead to your answer and give a reason for your answer. I didn't put enough room on the paper, so we're going to do it on lined paper. So free response 3, Unit 7 or Chapter 7 test review. Oh, there go my lights. Sorry for the adjustment. Let's see here. Okay, so for part A, g of 3, can y'all see? It's going to be from 0. Now replace the x. We replace the x with 3, so we're going to replace this x with 3. F of t dt. We're not doing anything with this. What this means is we need to find the area from 0 to 3 under the curve of f. So we've done this area a lot, but this is going to be 1/4 of pi r squared. Now r is 2, so 2 squared is 4. And then 2 squared is 4, so what's this area? This area is just pi, right? And then the area from 2 to 3 is going to be -1/2, is that it? So the base is 1 and the height is 1, so we have 1 times 1 over 2. So this is equal to pi, oh, not plus, why not? What is that triangle? That little triangle is below the x-axis, so it's going to be 1 minus 1/2, sorry, pi minus 1/2. Okay. Next is g prime of 3, which you could not find unless you found this. So g prime of 3 now we know is f of 3. F of 3 is just the coordinate point at 3. So the coordinate point at 3, f of 3 equals -1. And then g double prime of 3, I'll move it up if you can't see it. So g double prime of 3, we're going to put it in here, okay? F prime of 3, now this says find the slope of 3. So if this is a line, I could find the slope of it. But let's look at 3. What's happening at 3? At 3, there's a corner. Is there a derivative at a corner? No, so this is undefined. You could also say does not exist. So undefined because there's no derivatives at corner because of a corner or a sharp turn. Corner. Okay. Show the computations that lead to your answers or give a reason for your answers. So y'all, these are the computations that led to my answers up there. Okay, let's look at B. Find the x-coordinate of each point of inflection of the graph of G. So this happens a lot, you guys. We're asking about G, but they gave us a graph of F. So we don't just look here for point of inflection, okay? There's actually none on that graph. We're talking about G. So G will have a point of inflection when G double prime changes. These are those definitions you wrote in first semester from negative to positive or positive to negative, okay? So let's look at G double prime. What was G double prime? G double prime, I have it on my paper somewhere. G double prime is F prime, okay? And F prime is the slope. So we want to know, when does our slope change from negative to positive or positive to negative? Or, sorry. So let's look at the slope of this graph, okay? Positive, 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 0, negative, negative, negative. So right here, we have a change from positive to negative. So we're going to say at x equals 0, F prime, which equals G double prime, changes from positive to negative. I'm sorry you couldn't see that. There you go. Okay, now this slope is negative, 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 negative. Here it changes to positive, 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 but this is a corner and we've already declared that the F prime of 3 is undefined, so we can't include that. So you would lose a point if you include that. Do not include or count x equals 3 because of corner. Okay, the derivative's undefined. All right, moving on quickly. C, what does C say? On the closed interval, what is the absolute minimum value of G again? So to find a minimum, how do we know when a minimum is? It's when the derivative equals 0 and a minimum changes from negative to positive. But what is G prime equal to? So G prime is equal to F, okay? So G prime equals F. Now we need to find out when the points, because F are the points, change from negative to positive, okay? So start from the left. These points are positive, 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 not slope. We're looking at the points. Positive, 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 switches to negative. Is that what we want? No, that would be a maximum at 2, because it goes from positive to negative. Negative, 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 positive. So this happens at x equals 4. F of x equals G prime of x switches or changes. Switches from negative to positive. Okay, that's, really quick. You would have 15 minutes to complete that, and we just did it really quick. All right, let's look at FRQ 4. Consider the Diffie Q that this should just, this should really be review. So let's look at your slope field. So we should have, what's this going to be? Is this going to be 1 and 1, and then this looks like 1/2 or 1/4? These are all zeros. I'm looking at the answer key. I'm not this fast. And then negative, negative, and negative 1/2 or negative 1/4, one of those. Okay, now I show nothing here. How come there's nothing here? It's because when, this is x, this is y, when x equals 0, we're dividing by 0, which is undefined. So there should be no slopes, okay? No slopes on this y-axis, nothing. On the axis provided, sketch a slope field. Okay, we did that. So you should be able to check that. Let's answer C, and then we'll do B on the another piece of paper. Describe all the XY coordinate points for which the slope of the tangent line would be positive. Give a reason for your answer. So do you see here, this is 0, and then these are negative, and do you agree these are all positive here? So what we're going to say is we're going to say all y values greater than 1. So all the y values greater than 1, but x can't equal 0. So think about the numbers here. Any y value greater than 1 will be a positive divided by a positive. So that's pretty good. Yeah, let's review. Okay, so let's do B, where we're solving the Diffie-Q. This should be like hard, but you should be able to do it now because we've done so many. We've been practicing this for many, many months, many moons. Okay, here we go. Step 1, separate the variables. So see this y minus 1? The only way to move that is to divide both sides by y minus 1. So we're going to get 1 over y minus 1. 1 over y means we're going to have ln here. Now this is not x squared. This has to say 1 over x squared dx. So good review here. Next step, don't hate, integrate. So we're going to integrate. Oops. Now this is the ln of y minus 1. But this is not the ln of x squared. Okay? 1 over x squared changes to x to the negative 2. So we're going to add 1 and divide by the new power. So y is a power of 1. It becomes ln. 1 over any other power. Add 1, divide by the new power. This confuses kids all the time, so I'm going to rewrite this. ln absolute value y minus 1 equals negative 1 over x plus c. This was like margin work, and now we're going to find c, F-I-N-D, find c, and we have a coordinate point, yeah? Coordinate point is f of 2 equals 0. All right, so this is x and this is y. So we have the ln, the natural log, of 0 minus 1 equals negative 1 over 2 plus c. See why the absolute value is there now? So now we have the ln of 1 because we have the absolute value of negative 1 equals negative 1/2 plus c. What is the ln of 1? So the ln is base e. So e to what power equals 1? That's e to the 0 power equals 1. So c is equal to 1/2. This is my find c. This is off on the side of the paper. Oops. Scroll, scroll, scroll up. Okay, so now I'm going to put c back in, and I need to solve for y. And I have 1.5 minutes. Can we do it? And I ran out of paper. That's okay. That's okay. Here we go. ln of y minus 1, oops, equals, I leave the x, right? And I have 1/2. Sweet. How do we undo the natural log? The natural log, we take the e of both sides. So you go e, hiya, karate chop, and we have y minus 1 equals e to, this is all in the power of e. One more step. Ready, get set, solve for y. And I'll show you an extra step if we have time. Ta-da! Okay. Extra step. I just want to make sure I got it right. Guess what? Guess what? I did get it right. And the AP exam, I'm looking at the solutions. It didn't do an extra step, so it left it like this. So congratulations. We get to leave it like that. All right, that's it. Thanks for watching.